This is Geometry, Semester 1. This is the third unit called Area and Perimeter. And it's the second lesson called Area and Perimeter of Triangles Practice. It's on CreatorMathcom. You might have to search on Google for CreatorMath.weebly.com to find the site. The instructions are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. So normally I try to model that for you. So here's the site, CreatorMath.weebly.com. Let's see, here's the home page. This is what it should look like when you get there. If it does, all of the composition book information, students, is on this home page. Just scroll down until you see composition book, the picture of the composition book, watch all the videos, follow all the instructions, you'll be good. So we're going to go to geometry. That's where all the notes are, all the videos are, all the problem sets, and the vocabulary. So notice right here it says vocabulary, geometry, practice, study, PDF. That's got all the vocabulary for the entire year in this course. It will give you all the answers to every vocabulary practice you've got, as long as you can get that thing open and look up the vocabulary you need. So let's find the table of contents for the semester we need. This happens to be a lesson for semester 1. It says Geometry Table of Contents. You should have written this entire table of contents on pages 2 through 6 of your composition book a long time ago. If you haven't, stop what you're doing now and go ahead and do that now. We're going to find the lesson that we're in. And it is Area and Perimeter. We are on lesson number 2. So 1, 2. It's this one here. Area and Perimeter of Triangles, page this. So I'm not going to say the page number because I want you to go find this table of contents on the website for the day and age which you're watching this video. By the time you watch this video, these page numbers will likely be different. So don't use this video for that. Go look at the actual table of contents. Now, this tab is notes, this tab is problems, this tab will be video solution. So if we click notes, this is what goes on those pages of your comp book. It does take a second for mine to load up, and every once in a while, like I think right now, I'm going to load it twice. I haven't had to load it more than twice though, knock on wood. Okay, there we go. Once it loads, you'll be able to open it up as large as you need to be able to see it, to put these notes in the comp book on the right pages. All right, so it talks about triangle, how to calculate the perimeter as the distance around a shape. So we just add up the side lengths of the shape. And area of a triangle is 1/2 base times height. Why? Because if we had a rectangle and it had a base and a height, a triangle is exactly 1/2 of that. So the area of a rectangle is base times height, and then we just take a half to get a triangle. The only thing we need to take into consideration is that we need the perpendicular height. So let's see, 1/2 base times height. We tell you what these 3 dots means. Therefore, here are some problems to put into your comp book. Here's some vocabulary. This is important. Height of a triangle, the perpendicular distance from the base to the vertex. So we're going to talk about perpendicular height. That's very important. A lot of your calculations involve perpendicular heights in geometry. So you're going to want to pay particular attention to that. Perpendicular means crossing at 90 degrees. A right triangle is one angle of 90 degrees. So a right triangle has one angle of 90 degrees. These 3 dots right here mean therefore. Perimeter is the distance around a shape, and area is bounded with a perimeter. There you go. So here are some problems to put into your comp book on the correct pages, and you can solve those if you can. And let's get on with the problem set. You can go straight to this problem set if you can't solve those. This one's filled out a little bit for us already. That shouldn't be too much of a problem here. The first one reads, given the following triangle, if AC is 3 units, so here's AC. It's a little bit hard to see. AC is this side. 3 units, AB is 4. Here we go, 4 units. And BC is 5. That's across here, 5 units. A 3, 4, 5 right triangle. So what's the area? We start with area equals 1/2 base times height. The base is the distance across the bottom here, and the height will be perpendicular to that. Notice it's a right triangle, so we know that this length of 4 is the perpendicular height, right? So this right here would be perpendicular height. And that's very important. You'll see us talking about perpendicular height all the time. And that way, if you had a triangle like this is not the height, and this is not the height. The height is the perpendicular height, which would be this here. And we would have a 90 degree, and this area here is that perpendicular height. All right, so with that, let's keep going. Given the following triangle, if AC is 3, AB is 4, and BC is 5, so 3, 4, 5, it's same dimensions as prior. What's the perimeter? Oh, let's finish the actual calculation here. 1/2 base times height. There's a half. The base is 3 units. The height is 4 units, perpendicular. 3 times 4 is 12, divided by 2 is 6. Units times units is units squared. 6 units squared. Now we're going to find the perimeter of the same triangle. All we have to do is track around the outside of it. We go 3. 3 plus 5 is 8. 8 plus 4 is 12. 12 units to the 1 power. Why is it to the 1 power? Because you're adding these. 4 units plus 5 units plus 3 units. These would have to multiply to have powers on them. Since they're adding, they all stay u. So you end up with u, and 3 and 4 is 9, and this 12. Right? So to the 1 power. And typically you won't show feet to the 1 power. We show it here trying to emphasize that it's a length or a distance, not an area. Given the following triangle, if AB is 8 units, so this is AB at 8, AC at 6 is here, and BC at 10, so a 6, 8, 10 triangle, right triangle. What's the area? Area equals 1/2 base times height. Base in this case is 6 units. Height perpendicular, we know it is because it's a right triangle, is 8 units. 6 times 8 is 48. Divided by 2, 24. Unit times unit is unit squared. Remember the difference between multiplying 2 units, which gives you a power, and it's just like with an x. X times x is x squared, you guys. X plus x is 2x. And this often gives students pause, all right? But put that in the back of your mind and think about it. Multiplying two variables like this, unit times a unit gets a unit squared. That's the multiplication case. Adding, like in perimeter, just adds them all up and you get a number in front of the units. All right, given the following triangle, it's the same thing. It's 8, 6, and 10. What's the perimeter? Just add up around the distance, around the length, around the outside. So 6 and 10 is 16, plus 8 is 24. 24 units to the 1 power. All right? Given the following triangle, if AC is 12 units, AB is 9 units, and BC is 15 units, what are the areas? So we have 12 here at AC. Oh, I got a cat climbing across my desk right now. Come here, cat. Okay, 12 units is AC. AB is 9 units here, and this one's 15. So what do we have? We've got area. 1/2 base times height. Area equals 1/2. Here's a base, 12 units. Put that in. Height, 9 units. 9 times 12 is 90 is 108. Divided by 2 is 54. Unit times unit is unit squared. 54 unit squared is the area. Remember, area is this. That contained by the perimeter. Given the following triangle, if AC is 12, so here we go, 12, 9, 15, what's the perimeter? Just add up going around. Perimeter is the distance around a shape. 12 and 15 is 27, and 9 is 36. 36, it's units to the 1 power because it's units plus units plus units. And in this case, 12, 9, and 15 to get 36 units to the 1 power. That's a length, not an area. All right, we're given this one. Given the following of BC is 5. So here's BC here. 5 units, but notice the tick marks around this thing that tell you all sides are an equal length. So this must be 5 units. This must be 5 units, right? So if we want the perimeter, we're just adding them up. 5, 10, 15. 15 units to the 1 power. This one is 10 units here, so they tell us 10 units on AB, A to B. AC is here, 8 units, and BC is 9 units. So we're just adding this up, right, to get perimeter. Oh, they're asking for area. Let's be a little careful. They give us the perpendicular height here of 12 units. So this says height, and I messed it up a little bit with my drawing, but it's got a dimension here and here, and a 90 degrees here. This height is 12 units. So we're going to do 1/2 base times height. The base is 8 units, and the perpendicular height is 12. So we're not going to go with these dimensions over here. We're going to go with the given. And I'm not sure about the way this works out, but here's an illustration of this airplane. We're also talking about another name for perpendicular height is altitude, A-L-T-I-T-U-D-E, right, altitude. 8 times 12 is 80, 96. 96 divided by 2 is 48. So 48 unit times unit is unit squared. 48 units squared. That gives us the area. Area is this bounded by the perimeter. Given the following triangle, AC is 8. It's here. BC is 10. BC is 9. Here we go. BC is 9. AC is 8. Okay, 8, 10. AB. There we go. 8, 10, and 9. That's correct. The height is 12. I don't like the way these are drawn, and I don't like the numbers involved, but okay, I'm going to go with them for now. We'll worry about reworking them later. What's the perimeter? Start here and go 8, and 9 is 17. 17 plus 10 is 27. 27 units to the power 1. Given the following, let's see. Yeah, I don't like the dimensions, but we're going to go with them anyway, you guys. Don't worry about that for now. That's a technical problem that I wish I had handled better. So they label the sides. AB is 12. AC right here is 15. And BC is 5. So do they want the perimeter? They want the area. So we don't care about this one, and we don't care about this one. All we care about is the perpendicular height over here of 7. 1/2 base times height. 15 is the base, units. 7 is the height, perpendicular. 15 times 7 is 70, plus 35 is 105, divided by 2 is 52.5, and unit times units is units squared, 52.5 units squared. Same thing, now we're looking for perimeter. Let's go right back up here and look at perimeter. Let's go 15, and 5 is 20, and 12 is 32. So 32 units. Notice this is the power 1 because it's perimeter, a distance or length. Notice this is to the power 2 because it's an area or a two-dimensional measure. Base and the height being the 2 dimensions, which is also horizontal times vertical, which could also be length times height. So given the following triangle, AC is 6 units. Okay, where are we? AC, 6 units. AB is 8 units. Here, 8 units. BC is 3 units. Here. They're telling us the perpendicular height is 8 units. That's this here. What's the area? We're going to ignore some of the problems with the dimensions. We're just going to go with base times height. Base is 6 units. Perpendicular height is 8 units. So 6 units times 8 units divided by 2 because it's 1/2 base times height. 6 times 8 is 48. Divided by 2 is 24. Units times units is units squared. 24 units squared. Given the following, what have we got? Oh, same dimensions, now we want perimeter. So start here and go 6. 6 plus 3 is 9. 9 plus 8 is 17. 17 units to the 1 power. Given the following, what's another name for height? So this is the way they're labeling height. It's either altitude or perpendicular height or both. So you get to mark, it says more than one answer may apply. This is either an altitude or a perpendicular height. Those are synonymous for our situations. Given the following triangle, side A is 5 units, side B is 12 units, side C is 13 units. What's the area? 1/2 base times height. You got a 12 unit here for base. You got a perpendicular height of 5. 12 units times 5 units divided by 2. 12 times 5 is 60, divided by 2 is 30. U times U is U squared. 30 U squared would be area, and area is this bounded by the perimeter, all of this inside here. Given the following triangle, same dimensions, what's the perimeter? 12 and 5 is 17, plus 13 is 30. Oh, look at that. The area and the perimeter equal the same thing, but notice the 2 different units. This is unit squared because that's an area. This is unit to the power 1 because it's a length. This one goes distance, distance, distance. No squared units in that. because you're just adding up the links. All right, what is the symbol? This one is alpha. It looks like this. This is an alpha. It is the Greek letter alpha, which is their A, right? We often use in geometry, we'll use Greek letters for variables of an angle. What's this angle measure? Instead of using an X, we don't like that because we use the alpha and beta right here. We use a beta. Greek letters, probably because, not probably, but because geometry comes largely to us from the Greek system where they were originally labeling these things with Greek letters as variables. The symbol here, this is beta, looks like this, and that's it right there on the computer. On the computer it looks like that. Kind of strange, but it's a Greek letter beta for B. These are interesting. They say, redraw the following triangle in your notes. If AB is 5, here's this one, AB, 5. If BC is 7, and AC down here is 13, what can be said about this triangle? So here's what you got. This is a drawing of it. Here's the 13 here along the bottom. That's 13 long. Then let's take this side at 5, and this side at 7, and add them up. They're only 12. If you're going to have 3 sides to a triangle, and the longest one is 13, these 2 shorter sides must be long enough to span the distance of 13. They must be greater than 13 and have some value above 13. If they're only 12, they can't even reach to the end of this to make a triangle. So I don't know if your brain can see that from my explanation. In class we would take a straw with 5, a straw with 7 long, and a straw with 13 long, and we would ask students to form a triangle, and of course they couldn't. So it cannot exist because the longest side is greater than the 2 smaller sides combined. Let's try it again. Redraw the following triangle. This is 17, this is 6, this is 9. So I know it looks like a triangle here, but let's lay down these sides and see if this really works. 17 is here, 6 is one side, 9 is the other. Even if you put these end to end in a straight line, this only adds up to 15. 15 is smaller than 17. It can't work. It cannot exist because 17 is greater than the sum of the 2 shorter sides. All right, play around with a couple straws, 3 straws, and see if you can make it work by measuring the sides of the straws and make the 2 shorter sides combination shorter than the longest side, and you'll see you cannot form a triangle. Here's a third example. AB is 23, okay, and the 2 shorter sides are BC is 5 and AC of 12. So take the 2 shorter sides and put them end to end, 12 and 5. That only adds up to 17. The longest side is 23. This side is too long for these 2 sides to even reach to attach here. It cannot make a triangle. It cannot exist because the longest side is greater than the sum of the 2 shorter sides. Why are units for perimeter raised to the power 1? Because perimeter is one-dimensional. It's a distance. Why are units for area to the power 2? Because it is 2-dimensional. It is length times width. And think of the third dimension, right? Third dimension would be if this is x, this is y, this one here is z, x, y, z. So this would be 3D. A 3D has units to the power 3 because it's 3D. So 1D, 2D, 3D. Power 1, power 2, power 3. Power 1, power 2, power 3, 1D, 2D, 3D. Do you see the relationship? I hope so. It makes things a lot easier if you can figure out this big picture. All right, what are the common 3 dimensions used? More than one answer may apply. Length, width, and height. It's true. This would be length. This would be width. This would be height. And horizontal, vertical, and depth. So horizontal, vertical, and depth. These are each acceptable for those 3 dimensions that we commonly talk about in geometry and life. Given the following graphic, what is the area? Well, the perpendicular height here is 5, because that's the y value. Remember, we have x comma y in a coordinate. So we go out x, up y. This thing is 5 high. That's the perpendicular height here. So 5 units in height. We go out this way on the base from 0 to 9. That's 9 units on the base. 1/2 base times height. 9 times 5 is 45. 45 divided by 2 is 22.5. Unit times unit is unit squared. So 22.5 units squared. And that area is this within the perimeter. What's the following area? Same thing now. Interestingly enough, this base is 9 and this height is 5. So I know the two triangles look very different. Look at this one, a right triangle and a triangle that's sort of, got an apex here in the middle rather than over here at a right angle to the base. It's over here in the middle. It looks totally different to you, but guess what? The area calculation is exactly the same. 9 units times 5 units, 9 times 5 divided by 2, 22 and a half. Both of these triangles have the exact same area. Hope you find that as interesting as I do. Make sure you're matching up the title of this lesson. This is Geometry or Practice or Set of Practice Problems. Geometry Semester 1. It's the third unit called Area and Perimeter, and it's the second lesson called Area and Perimeter of Triangles Practice, and it's on CreatorMathcom under the Geometry tab. Hope that helps.